Okay, so in the last video we looked at the merge method. So this is a method that is going to be very useful in completing the MergeSort sorting method. So again, what we do is we basically assume that the original array, the first half is sorted and the second half is sorted. And then we are writing code that will merge these two halves into one big sorted array. Now, I've forgot something important. At the very end, you need to copy the temp array back into the original array. So basically, you need to have a loop that goes through the temp array and just copies every value over top of the original array. So basically, the 3 is going to go in here. The 4 is going to go in here. So you're just copying every value in. Okay, 7 goes in here. 8 goes in here. 9 goes in here. 9 goes in the next. Okay, so I'm just to speed this up. So you just basically have a loop that runs the length of the array and just putting each value into ARR. So you're just copying over the original values. Okay, so that's what you should do at the end of the merge method. Now, hopefully you did the merge method as an exercise and did it on your own, but if you were stuck and you need some help, here is a sample solution to the merge method. So if you remember, I have a blank merge sort, so we're going to come back to that in this video. And then here is the merge method here. So the first thing you do is to create a temporary array. But the trick is, instead of making this array the length of ARR, you're going to make it end minus start plus 1. Okay, so that should be the same thing, but this is going to be needed in order to get the recursive nature of MergeSort to work. Okay, this may be a little bit confusing, but we'll come back and have a look at this in a minute. Okay, and then as I mentioned in the last video, I is going to be start, j is going to be middle plus 1, and then x is going to be 0. So x is that little pointer that's pointing to the indexes of the temp array. Okay, and then here is kind of like your main loop. As long as I is less than or equal to middle and j is less than or equal to end, so as long as these are both still true, we're going to ask which one's smaller, ARRI or ARRJ. So if ARRI is smaller, we're going to assign temp at x to ARR at I. Okay, so you're going to put that element into the temporary array. Then you're going to update x, so x is going to go up by 1 and I is going to go up by 1. Else, so imagine ARR at j was less than ARR at I, then you're going to do the reverse. You're going to put ARRJ into the temp array at index x, and then you're going to update x and update j. Okay, so this will keep going. Now, if one of the halves finishes early, you're going to add the remaining elements of the subarray that's not yet exhausted, so the subarray that's not yet finished. So I have just two little loops here that basically say as long as I is still less than or equal to middle, so basically if we're not done the first half of the array, then we just have a loop that puts in the remaining values from the left-hand side, from the first array, into the temp array. And then we have a loop saying as long as j is less than or equal to end, so if the second array is not finished, then you're just going to put the remaining elements into the temp array. Okay, and then this one step that I forgot in the original video, but we're just going to copy the temp array elements into ARR. So this is a loop that just goes through the temp array and just copies every value and puts them into ARR. Okay. Oh, this is also important here. This might be a little bit confusing. So instead of just saying ARR Z equals temp Z, we're saying start plus Z. So what is start? Start is one of these parameters here. And we're going to assume that that's the starting index of the array. So we're going to say start plus z here. And again, this is a little confusing as to why we're doing that, but it makes sense in the next step in terms of the recursive nature of MergeSort. Okay, now I would invite you, hopefully you've tested this method and that it works, because if there's one little mistake somewhere, then none of this will work. So make sure you test the merge method, and just make a little tester method, create an array in which the first half is sorted, second half is sorted, and then call the merge method and print the array again and see if it worked. Okay, merge sort. All right, so what we're going to do here, I've actually got a diagram of a completely random array. So this is not, the first half is not sorted, the second half is not sorted, so this is just a completely random array. So how does merge sort work? Well, what we're going to do is kind of break this array down into halves at the very beginning. So this will be 10, 3, 8, 1, and the second half will be 9, 2, 7, 5. Okay, and we're not merging, we're not doing anything yet. We're just kind of separating the original array into two halves. Now, what if the original array had an odd number of elements? Well, that's okay. It's just that maybe the first half will have 5 elements and the second half will have 4, and that's fine. Okay, now you're going to break down these halves into more halves. Okay, so now we have a little array 10, 3 and a little array 8, 1, 9, 2, 7, 5. Okay, and it's important at this stage to know that we're not actually physically creating, we're not going to be creating new arrays. Like that would actually be a lot of arrays, especially if our original array was quite large. We're not creating all of these temporary arrays. We're simply just changing the values of start, middle, and end. And that allows us to kind of look at each portion of an array. Okay, so let's come back to this. So I'm going to keep going one more time, and I'm going to divide each of these arrays into halves. Okay, so we keep doing this until we have little one-element arrays. Now we merge each pair. So 10 and 3, we're going to call our merge method on these two. So the 3 is first, and then the 10 is second. There. So these two arrays have been merged. I'll say this once again, that they're not actually two arrays. It's picture this as one array in which the first half is sorted and the second half is sorted. And we're just running our merge method and copying the values back into the original array. Okay. Now let's look at the next two arrays. Okay, or it's once again it's a single array. We're just kind of pretending we're splitting them into two. So now we're going to merge them. 1 goes here and 8 goes here. Okay, these two, 2 and 9, and then 5 and 7. All right. Now we repeat this. So now we have two subarrays in which the first half is sorted and the second half is sorted. So we're going to merge these two. So we get 1, 3, 8, 10. And then we're going to look at these two subarrays. So we have 2, 5, 7, and 9. And then finally, we're going to do one more merge with these two subarrays. So we get 1, 2, 3, 5, 7, 8, 9, 10. And then we are finished. Okay, so this is a bit abstract, and it kind of looks like there's a lot of temporary arrays that are being created, but there's actually only one temporary array being created, and that's the one in the merge sort. But we're actually just partitioning the array using the start, middle, and end parameters. And they basically jump around to kind of focus on certain sections of our array. All right, let's go back to the code here. So how does this merge sort method work? Well, we're going to do a little trick here first. So this method is just going to have one line of code. It's going to be called do merge sort, ARR, and then 0 and ARR.length -1. Okay, so in fact, we're going to create yet another helper method called do merge sort. All right, now this is going to be the recursive method. So this method takes in the array reference and then just two parameters, start and end. Okay, so this just represents the start of the array, and this is the end of the array. Okay, so we're going to basically, this is going to be our recursive case. So we're going to keep running this code as long as start is less than end. So the moment when they crisscross, so when start gets equal or larger than end, then we're going to stop these recursive calls. But as long as start is less than end, we are going to figure out where the middle index is. So that's going to be halfway between start and end. Okay. And then we're going to do MergeSort. So we're going to call this method again on, okay, so ARR is the array reference. And what I want to do is I want to define the first half of the array. So the first half starts at start, and the end of the first half of the array is going to be middle. And then we're going to do MergeSort on the second half. Okay, so this is the first half of the array. And then the second half of the array is going to be middle plus 1 up to end. And then once I've done that, I'm going to merge together. Start, middle, and end. Okay, that's it. This should compile. Yeah, and we are finished. Very complicated though. What is happening here? So again, as long as start is less than end, what we're going to do is define a middle point. And then we're going to do MergeSort on the first half. So we're going to do this again. So what this essentially does is kind of like what my picture was doing. It kind of breaks down the first half all the way down to little one element subarrays. Okay, and then we're doing it again on the right half. So this just calls do MergeSort over and over and over again, breaking it down into one element subarrays. And then once we get down to the little one element arrays, we're now going to go back up the recursive ladder, and we're going to merge each one of these arrays. So that's when we get to this part, when we're actually the last four steps, when we're merging all of these arrays into larger arrays. All right, this this is complicated. In this course and on the AP exam, they won't ask you to write the code for MergeSort. They usually just want an overall kind of understanding on how it works. So you need to know that MergeSort is recursive, and then perhaps they might have a diagram like this, and they might ask you to show the steps of what would your array look like at each step of the MergeSort algorithm. So you should be able to explain that the MergeSort basically divides an array into two halves, and then into 4 halves, and then into 8 halves, all the way down into single element subarrays. And then we merge each pair into 2 element arrays, and then we merge each pair into 4 element arrays, and then we merge those pairs into 8 element arrays, and then we just keep merging until we're back to the original size array. All right, so I am going to leave it as an exercise for you to test out your MergeSort method. So make another class that tests out MergeSort, and then compare it to SelectionSort and BubbleSort. So you can use that current time in milliseconds feature to actually time the sort, and then compare them. All right, so I hope this made sense. It is very, very confusing to understand the full recursive nature of the MergeSort algorithm. If you do kind of get it, that's great. I'd be super happy if you fully understood the merge method. Hopefully we all understand how this method works. And then if you have just some insight into how this MergeSort method works, then that's great. All right, thanks for watching, and we'll see you in the next video.